Good morning, students. Today I want to give lecture about the chemical properties of alkenes. That is of the topic of hydrocarbon, of course. Alkenes, these are the double bonded compounds which are reactive than that of the alkanes due to presence of the pi bond. Normally in alkane we'll observe sigma bond, but in alkene we'll observe one pi bond between the carbon carbon, and that's why they follow the electrophilic addition reactions. The different reactions of the alkenes which are given below. In that, carbon carbon double bonded alkene. So this alkene that can be combined with halogen atom, halogen molecule X2 in presence of CCl4 as a catalyst. It gives CX and here both halogens are attached to the adjacent carbon atom. That's why this type of dihalide is called as vicinal dihalide. Next reaction with ethene, CH2 double bond CH2 ethene reacts with chlorine gas in presence of CCl4. It gives 1,2-dichloroethane. It is vicinal type of dihalide. Later on in this topic, we want to see the propene reaction with propene, and that reaction is the bromination reaction. In this bromination reaction, when propene reacts with bromine gas in presence of CCl4, here attachment of Br to the doubly bonded carbon atom, and this follows the 1,2-dibromopropane. It is a colorless compound. So addition of bromine in this reaction, which is useful test for the double bonded, and that's why in this red brown color of the bromine that rapidly disappear into the colorless tetrachloride or colorless type of solution. Addition of hydrogen halides, that is also called as hydrohalogenation. So addition of hydrogen halides HX like hydrogen chloride, hydrogen bromide and hydrogen iodide, they converts alkene into the corresponding alkyl halides. Now here alkene when combines with HX means hydrogen halide, it gives alkyl halide. And the order of the reactivity of hydrogen halide is HI greater than HBr greater than HCl. Now some addition reaction we'll see with the symmetrical type of alkene. In that ethene reacts with HBr, it gives CS3CH2Br means it is what ethyl bromide or bromoethane. Next one ethene reacts with HBr. Here it gives Br means it reacts with Br2 actually. So here uh, it reacts with ethene reacts with HBr. Here Br we can attach either on first carbon or second carbon. Now second stanza, next stanza of this reaction that we want to see of addition reactions of HBr to the unsymmetrical alkene. In that propene reacts with HBr. Here addition of Br goes to doubly bonded carbon. And here two possibility. First of all, Br attach to the first carbon atom from the right side. So we'll get CS3CH2CH2Br. It is one bromopropane. It is the minor product. And second possibility, Br attached to the second carbon. So we'll get CS3CHBr CS3. So it is the 2 bromopropane. It is the major product. Why it is major product? That we can study according to the Markovnikov rule. Markovnikov rule states that when an unsymmetrical reagent added to an unsymmetrical alkene, then here unsymmetrical reagent means HBr. In that negative part means Br minus goes to that carbon alkene which has less number of hydrogen atoms. So middle carbon has got less number of hydrogen atom, and that's why we'll get 2 bromopropane is the major product. So it is the Markovnikov rule. Anti-Markovnikov rule is reverse of that one. Anti-Markovnikov rule invented in 1933 by the MS Crash and FR Mayo discovered. And by this rule, we can get the next reaction of the propene. Propene reacts with HBr, it gives 1 bromopropane. And next reaction is of 2-methyl prop 1N plus HBr in presence of acetic anhydride, it gives 1 bromo 2-methyl propane. Now this addition we'll see according to anti-Markovnikov rule. Anti-Markovnikov rule said that when an unsymmetrical reagent add to an unsymmetrical alkene, then negative part of the reagent means Br minus goes to that carbon of the alkene which has measure the number of hydrogen atom. Among the CH and CH2, CH2 carbon has more the number of hydrogen atom across the carbon-carbon double bond. That's why this Br goes to CH2. So we'll get the product CH3, CH2, CH2, Br. And in next reaction also in same way we'll get 1 bromo 2-methyl propane. Later on addition reaction with sulfuric acid we'll see. In this reaction alkene reacts with sulfuric acid which is cold and concentrate. This addition also we'll see according to Markovnikov rule. According to Markovnikov rule we'll get here CH3 CH2 OSO3H, it is ethyl hydrogen sulfate, but it is not the stable product. This ethyl hydrogen sulfate that we can again continue the further reaction, and from that we can get the further product. This react continuity of this reaction we'll see over here. CH3 CH2 OSO3H ethyl hydrogen sulfate hydrolyze in presence of water molecule by heating. In this HOH bond going to break, and here by breaking this bond of HOH we'll get CH3 CH2OH. It is the ethyl alcohol or ethanol along with H2SO4 regenerate in this reaction. Later on, next reaction we'll see regarding the isopropyl hydrogen sulfate, which combines with water. It gives propane to all plus H2SO4. Later on, 2-methyl prop 1 in plus water molecule with acidic medium, it gives 2-methyl propane to all. Later on, we'll see the ozonolysis reactions of the alkenes. Addition of ozone is called as ozonolysis. In this ozonolysis, alkene actual reaction we'll see over here, and that actual reaction we'll see from this one. CH2 double bond CH2 ethene combines with ozone gas in presence of CCl4 catalyst. So here oxygen atom added between carbon top side as well as from bottom side. We'll get CH2 COO CH2. So break this bond in this way, and we can get ethylene ozonide, or you may say triozonide, which can be hydrolyzed with zinc dust. So breaking a bond in this way, we'll get HC double bond OH plus HC double bond OH plus ZNO. Means what we'll get? Two molecules of the formaldehyde along with zinc oxide. In same way, we can see the reaction from propene. Propene undergoes ozonolysis, it gives intermediate propene ozonide, and from this propene ozonide, which can be hydrolyzed in zinc dust, it gives acetaldehyde along with formaldehyde. Later on, next topic we'll see hydroboration. Hydroboration in that oxidation of alkene we'll see. In oxidation of alkene, we'll see ethene 6 molecules reacts with B2S6 or HB32 molecules diborane. In presence of tetrahydrofuran means THF, it gives 2 molecules of CH2 CH2 3 times B. Yeah, then this intermediate again further reacts with hydrogen peroxide. It gives 6 molecules of ethyl alcohol and plus 2 molecules of BOH thrice. Now, next reaction we'll see from propene. When propene reacts with diborane in presence of THF, it gives tri N propyl borane, which can be treated with hydrogen peroxide. In presence of NaOH, it gives 3 molecules of CH3 CH2 CH2OH, that is called as propane 1-ol along with BOH thrice. Last stanza is of polymerization. In polymerization in that molecules are repeatedly combined together gives long chain of the molecules, that is called as polymers, which can be obtained from the monomer. Example for this one, ethene. Ethene when reacts under high pressure, it gives CH bond CH2 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 bond, and finally it gives CH2 CH2 n times, that is of polythene, means polymer. Later on hydroxylation we'll see. In hydroxylation, here alkenes reacts with cold and dilute potassium permanganate to form glycol. Ethene plus HOH means water molecule plus oxygen, which can be obtained from oxidizing agent like KMnO4, and we can get from that we can get here ethene 1,2-diol. Now propene reacts with HOH plus oxygen. In place of alkaline KMnO4, it gives propane 1,2-diol. So in this way, we can perform hydroxylation reaction. Later on oxidation reaction we'll see. In case of oxidation reaction, uh, the previous reaction is also called as Bayer test. Now oxidation reaction. When propene reacts with KMnO4 in H plus oxidation, it gives ethanoic acid plus carbon dioxide plus water. Then 2-methyl butene in presence of KMnO4, it gives propane 2 in along with ethanoic acid. Later on uses of ethene. Where we can use ethene? Ethene we can use as a starting material for preparation of alkyl halide, alcohol, aldehyde, ketone, acids, etc. Ethene and propene are also used as manufacture of polythene, polypeptide, those find use in polythene, bags, toys, bottles, etc. Ethene is used for artificial ripening of fruits like mangoes, etc. Later on, we want to see the topics of alkynes. In the topics of alkynes, alkynes are aliphatic unsaturated hydrocarbon which are containing at least one carbon-carbon triple bond. In that isomerization of the alkynes, we'll see. In isomerization, from same molecular formula, we can get the different structures. Example, here from ethane, we can get ethene, we can get ethane also. So here alkane, alkene, alkyne. Here difference of the single bond, double bond, and triple bond. And that isomerization we'll see from, and for that also we can give the IUPAC names. The lower alkynes means C2H2, also called as ethine or acetylene. C2H4 called as methyl acetylene, propine. C2, C3H4 is propine. Then C4H8 is butane or but1,1. In this way, we can give their IUPAC name as well as common name. Then preparation of alkynes. First method is industrial method. 6 molecules of methane plus 2SO2 at 173 Kelvin, it gives 2 molecules of ethane plus 2 CO2 plus 10 H2. Then CaC2 plus twice H2, it gives C2H2 plus CaOH twice. Second method is method of preparation of alkynes. In that, by dehydrohalonation of vicinal dihalide. In that vicinal dihalide, here we'll see uh, 1,2-dibromoethane, which can be combined with KOH. Then from that, we can get bromoethene, which reacts with NaNH2, it gives ethine. In this way, we can see the 1,2-dichloropropane also, plus alcoholic potash, it gives 1-chloropropane, and from that we can get propine. Later on, such type of higher alkynes are obtained by reacting metals acetylide with primary alkyl halide. Then terminal alkyne lithium amide, then alkyl 1 while lithium, and in same way we can continue for ethyne. Ethyne reacts with lithium amine, in that loss of ammonia. From that we can get ethylenium, that in presence of bromethane it gives but1 along with LiBr. Then propine reacts with LiNH2, it gives CH3C triple bond CLI prop 1 1Y lithium. In this, bromoethane, that is CS3 C, C triple bond C, then CCH2 CH2 plus LIBr. So what are the main product is called as pentwine. Later on, physical properties of alkyne. In that, physical properties of alkyne we can study on the basis of previous knowledge of the alkanes and alkenes. The less dense, these are less dense than that of the water. They're insoluble in water and quite soluble in less polar organic solvent like ether, benzene, carbon tetrachloride, etc. Their MPBP of alkynes increases with increase of their molecular weight or molecular mass. This table indicates the MP and BP of the corresponding double bonded compound. In that, ethine or ethene has the molecular weight 26, physical state is of gas, then boiling point 198, melting point 191 in this way. In same way, we can study about the propine, butone wine, pentone wine, and hexone wine. So, uh, after these physical properties, we can see the chemical properties of alkynes. In chemical properties of alkynes, we can study their acidity. The hydrogen bonded C triple bond C is has the acidic character. Lithium amide is the strong base and it reacts with terminal alkynes to form lithium acetyl with liberation of the hydrogen gas. We'll see actual reaction. When ethine reacts with Li NH2 by loss of ammonia it gives Sc triple bond Cli, that is methylenium ethanide, which can be further reacts with LiNH2 it gives LiC triple bond Cli along with ammonia. It is dilithium ethanide. Then propine with LiNH2 it gives CH3C triple bond Cli, that is lithium propionate. Now the order of reactivity of the alkane, alkene and alkynes as follows. Here Sc triple bond CH acetylene highly reactive than that of the ethene, which is reactive than that of the ethane in this way. Later on, we want to see the addition of dihydrogen. In that, some methods of preparation also we'll see in the previous chapter. Same we can continue about the dihydrogen, and that you can refer for the dihydrogen the previous knowledge of the previous chapter. Then addition of dihydrogen. After that, we'll see addition of halogens. For that, we'll see actual example. Whenever ethine reacts with Br2 in place of CCl4, it gives HCBr double bond CHBr, that is 1,2-dibromoethene, which reacts with Br2. It gives HCBr CBr H. It is 1,1,2 tetrabromoethane. Later on, we'll see the next topic of addition of hydrogen halides. In that, ethine plus HBr it gives CH2 double bond CHBr. It is 1 bromoethane. Along it reacts with further HBr. It gives CH3 CHBr2. That is 1 dibromoethane. It is of 50%. Later on, propine reacts with hydrogen bromide. It gives CH3 CBr double bond CH2. That is 2 bromopropene. With HBr it gives CH3 CBr CH3 2 dibromopropane. Then the order of activity of hydrogen halide is HI greater than HBr greater than HCl. Next method we'll see about the addition of water. In addition of water, here alkyne reacts with a water molecule with 40% H2SO4 in presence of 1% mercuric sulfate. It gives unstable product, and from this unstable by tautomerism. How tautomerism is there? By breaking of OH bond. This hydrogen removed from this one and it goes to this carbon. Now we'll get CH2 double C double bond O. It is of carbonyl compound. Now this alkyne reacts with water in presence of 40% sulfuric acid and 1% mercuric sulfate to form aldehydes or ketone, that is carbonyl compound. Ethine plus water with 40% H2SO4 In 1% HGSO4, it gives vinyl alcohol. By hot tautomerism, you see. Now, by breaking of this OH bond, hydrogen goes to this carbon and oxygen compact with double bond to the carbon. By tautomerism, will get SC double bond O and CS3. It is ethanol, means aldehyde or acetaldehyde. Propane reacts with water molecule with 40% H2SO4 and 1% H2SO4. It gives CS3C double bond CH2OH. It is by tautomerism again will get CH3C double bond CH3 means ketone. Is this ketone is called as dimethyl ketone or acetone or propanone. Later on, uses of acetylene. Ethine or acetylene is used in preparation of ethanol, that is acetaldehyde, as well as propanone, acetone, ethanoic acid, etc. It is also used in manufacture of polymer, synthetic rubber, synthetic fiber, plastic, etc. It is for artificial ripening of the fruits as well in oxidation flame, which is used for welding and cutting of the metals. Later on, the aromatic hydrocarbon, that topic we'll see in the next video. Thank you, students.